I was making a list with all the BFDI scenes that I consider scientifically interesting, and when I watched BFDI A15, there was a scene that caught my attention. It's this scene.
That's called the Doppler effect, by the way.
What I realized is that since the formula for the Doppler effect includes the speed of sound, we could use this scene to calculate it. The Doppler effect is the change in frequency of a wave when an observer is moving relative to the source of the wave. The frequency increases if the observer and the source are getting closer, and decreases if the observer and the source are moving apart. This is the formula for the Doppler effect, where f is the observed frequency, f0 is the emitted frequency, c is the speed of the wave, in this case the speed of sound on the Earth's atmosphere, Vr is the speed of the receiver, and Vs is the speed of the source. However, there is a problem. To calculate TV's velocity relative to the camera, we need to know where the camera is. I started rereading the part 1 of multiple view geometry in computer vision, but then I remembered one thing. All cameras in the real world make a perspective projection, so parallel lines meet at a point called the vanishing point or point at infinity. There is also another type of projection called the parallel projection. It's a special case of the perspective projection, but parallel lines in the world corresponds to parallel lines in the image. This type of projection can be approximated by a real camera if it's very far away from the thing it is filming. But for a true parallel projection, the camera would need to be an infinite distance from the scene. So I opened the image in GeoGebra to see if parallel lines in the world are also parallel lines in the image. And all of the parallel lines in the world that I checked are also parallel in the image. This means that the scene uses a parallel projection, so the camera needs to be very far away for the image to be created. If the camera is at infinity, the speed would be zero, since TB would always be an infinite distance away from the camera. The camera is probably not at infinity, but is still very distant from TB, so his speed would certainly be very small. So what TB called Doppler effect can't be related to the Doppler effect in real life. Instead, it could be a psychological effect where the pitch of a character's scream changes with time as they get chased, or it could be something else. There is one more thing I want to talk about regarding the camera's position. Since for a parallel projection, there needs to exist a large distance between the scene and the camera, it means that indoor scenes can't use parallel projection, since the scene would be blocked by the wall. So, if there is an indoor scene, or a scene in an enclosed space that uses parallel projection, we would need to explain how that scene is being captured. This is all I have for this video. Subscribe if you want to, and goodbye.